Hi, this is Deepak, founder of Xask Labs. We have created two AI products as a startup, Sorted Chat, which is an open source Golang application which you can download and run on your machine. And also we released a Sorted Interview AI agent for interviews. We are conducting a 1-day, 8-hour hands-on workshop where we teach you about Gen AI and AI agents. Now, this workshop is targeted for experienced professionals. We use your existing knowledge about databases, REST APIs, and the other things about software development, and we use that base knowledge to leapfrog your learning into AI. Let me walk you through what we have as part of the 8-hour workshop. So we have divided this 8-hour workshop into 4 parts. Let me walk you through the first 2 parts now. So the workshop starts with vector embeddings. Now Gen AI, the basis of Gen AI is vector embeddings. Even inside LLMs, they work on vector embeddings. So we start here. We talk about the semantic similarity as a concept. Then we move on to the distance function. We discuss about Euclidean and cosine distance functions, using which you can measure semantic similarity between 2 strings, text, or documents. We discuss in detail about vector embedding models. Now there are closed and open weight embedding models. So the closed ones, for example, are from OpenAI, from Amazon and Gemini, which you can only access using REST APIs. But the open ones are the ones that you can run on your machine. Now, because these models are really lightweight, you are going to run these models on your machines in the workshop, and we are going to do live demos. Then we discuss about the dimensions and the context window of these vector embedding models. So just like LLMs, these also have a context window, and dimension is a new term for each vector that they generate. Then we talk about the benchmark. So when you choose a vector embedding model for your purpose, you need to have some criteria. So one of the criteria is the dimensions, of course the context window, and then we have this benchmark called MTEB, Massive Text Embedding Benchmark. We dive into this in detail, and we show you how do we choose a vector embedding model for production applications. Then we talk about what are the interesting applications that you can do using vector embeddings, using semantic similarity as the base. So you can do clustering of text documents, you can do classification of text documents or strings or Amazon reviews or things like that. Then we directly deep dive into RAG application, which ties directly to vector embedding. So using vector embeddings, we explain you why we need RAG, even with the capable LLMs today. And we build a live RAG application. So the application that we build is chat with today's news. So we download 10 news articles from today's news, and then we build an application which will answer questions with respect to today's news. All right. Then in the second part of the workshop, we move into LLM APIs, and here we create our first agent without using any SDKs. So at the LLM API level, we discuss what are tokens, what is tokenization, what is the difference when you tokenize a sentence in Hindi or Telugu or other Indian languages versus English. We discuss what is the vocabulary size of an LLM and how does it matter. We discuss about how do you maintain context at the REST API level, how do you maintain context in a conversation. We discuss about how do you price a conversation, how do you calculate the price for a given conversation, and how to optimize it as well, because using input cached tokens, we can actually reduce the price of a conversation. And this is very important when we create agents, because agents are long running processes. Cost is really important. Then we also discuss at the REST API level what is temperature, top P, top K, and what are the log probabilities, and how at the REST API level we can request the model to give us log probabilities. We can choose our tokens using top P and top K. And after this, we create our first agent. So this first agent we create using pure REST APIs. We do not use any SDK at all. Now you can build this in any language. During the workshop, depending on the class's choice, we choose either Python or JavaScript. So this is our first agent that we create, and you will see each and every request going in and coming back from the LLM, and you will see all the tool calls happening. You will see the number of tokens spent in every REST API call, and we will be calculating the exact price. All right, let's move to the next part of the day. So the second half of the day we spend on building real agents. So here Now we start using SDKs. So we have a choice of OpenAI SDK or Google's ADK or Amazon Strand SDK, and there are others as well. So we choose one depending on the batch, and then we build a data analyst agent. So here we analyze a real database. So we choose a database which the AI agent has never seen, and we ask the agent to create a dashboard. So we create that agent in the class hands-on. Then we move on to creating a UX designer agent. So this agent, we use it internally all the time. We don't have a UX team. So we use this UX designer to create UX according to our requirements. We build this hands-on. Then we move on to creating a basic coding agent. So just like you are using Cursor, we build a simplified version of Cursor in the class hands-on. Then we discuss about guardrails. How do you protect against misuse of these agents in production? We discuss how do you price each of these agents. We discuss in detail about the architecture of each of these agents. We do a brainstorming session, and then we do a hands-on session. All right, in the last part of the class, we have a capstone project. Now, I personally really love this project. This is about building an on-call DevOps agent. So what we do is we build an AI agent which you can actually deploy in production. Now we know that all companies have PagerDuty alerts set up, and we have monitoring systems like Grafana and Prometheus. This agent is going to listen for production alerts. As soon as the alert happens, this agent is triggered. It finds out the root cause. It does the root cause analysis. To do this root cause analysis, it reads the documents, the documentation stored on Confluence or some other source. It reads the code. And based on that, it proposes a fix. Once it is satisfied with the fix, or it comes up with a fix, it creates a pull request and then sends you an email or an alert. So the agent does all of this, and the human comes and he just has to review this PR, and most of the times it is good, and he just merges it. So with this, we reach the end of the workshop. Hope to see you in the workshop. Thank you.